Okay, I want to talk about section 1.3 in the calculus textbooks, evaluating limits analytically. We have different techniques to evaluate limits. Always check direct substitution first. If there's no fractions, no radicals, most times you can usually just substitute indirectly like these. Can I put a 1 directly into this? If I put a 1 in for all my x's, I think I get an answer of 1. And this other example, I think I could also put in directly sine of 7 pi over 6. Those of you who are good know that 7 pi over 6 is a little bit bigger than 1 pi, or 6/6. So how much bigger than 6/6 is 7/6? Well, that makes a reference angle 1/6 pi. So I look up the sine of the reference angle to be 1/2. Sine of pi over 6 is 1/2. And down in this lower quadrant, I think it is negative, negative, cosine, sine. So the sine of this sine should be negative. Again, I don't know how well you are with your trig values. We're going to be talking about them extensively. At the end here, I'll teach how to do the trig table and give you some resources as well. So anyway, try direct substitution first if it works. The next one would be factor cancel. Okay, if we go to factor cancel, can I put 2 directly in? I always say try direct substitution first. If I put in 2, I get 4 minus 4 over 2 minus 2, which is 0 over 0. So then I try to factor. It's the difference of squares. I believe that allows the x minus 2's to cancel. And so that leaves me with this. The limit as x approaches 2. So what I'm going to do is I'm going to substitute in place of the x. I'll put a 2. 2 plus 2 makes this limit 4. Now, if we wanted to do this other one, it's a little harder one. If you put in a 3, if you put in a 3, 3 to the third is 27. 2 times 3 is, 3 squared is 9 times 2 is 18. What happened here? 18. Put in a 3 here, 9 times 3, 27. I believe it gives me a 0, and if I put a 3 in on bottom, I think I also get a 0, don't I? So it's 0 over 0. I tried direct substitution.
Because you wrote minus.
Sorry if I made a mistake. Let's see. Yeah, this would be a plus 18, right? So yeah, it should end up with 0 over 0. Regardless, let's see if we can factor this. I don't know how you taught to factor higher order polynomials. We could do synthetic division to factor it. I'm looking at this. I think it might be easier factored by splitting it. Can I take an x squared out of both of the first two? If I take an x squared, that leaves me an x plus 2. Can I take a negative 9 out of the second ones? That also leaves me x plus 2. Please notice that if I distribute, it would match what's up here, right? So anyway, now I have x plus 2, so I take out the x plus 2. If I take out the x plus 2, what remains is x squared minus 9. X squared minus 9 factors as a difference of squares, x plus 3, x minus 3. It's all divided by what? X minus 3. So now I'm left with this, and I'm going to substitute in a 3 for these x's. So I have 3 plus 2 times 3 plus 3. That would be 5 times 6, making my result 30. Okay, as I said, always try direct substitution first. If you see it as a fraction, that might give you 0 over 0, try factor cancel. That's what we did over here. See how it's a fraction? It gave me 0 over 0. Now, how about if you had least common denominator? That would be if you had a fraction in a fraction that still has to give you 0 over 0, but that would be like these. 1/2 minus 1/2 makes the top a 0 over a 0. So that tells me I have to rationalize, or in this case, use the least common denominator. Between two denominators, this and this, you can just multiply them to get a common denominator. So I'm going to use 2 times 2 plus x divided by itself so that I'm not changing the value of the function. When I multiply here, the 2 plus x's cancel, leaving me 1 plus 2, which is 2. When I multiply here, the 2's cancel, leaving me 2 plus x. But I have to use parentheses whenever I subtract. On bottom, you have all of this stuff. Simplify the top. 2 minus 2 is 0. I think it leaves me a negative x over this, which would allow those x's to cancel. Don't forget there's a 1 there. And we're going to replace the x now with whatever it said we had to replace it with. So if x is approaching 0, I'm going to put a 0 in for that x. So I put a 0 in for that x, and I think I'd get a result of negative 1/4. Okay, that was least common denominator. We also have rationalizing. Rationalizing, you only use that when you see a radical. It still is probably going to give you 0 over 0 like all of these. But let's see if I can find one that has a radical in it like this one. If you put in a 1, you get square root of 4, which is 2. 2 minus 2 is 0. And put in a 1, 1 minus 1 is 0. So it makes it 0 over 0. So I'm going to have to use the conjugate. The conjugate of a plus b is going to equal a minus b. So instead of the radical plus minus 2, it's going to be the radical plus 2. Oops, I wrote it backwards on top. I'm sorry, I'll fix that momentarily. Okay, let's make that small. Okay, I have the conjugate of a minus b would be a plus b, right? And what is a minus b times a plus b? A squared minus b squared. So if this is a, what's a squared? And if this is b, b squared would be 4. So what does that make the numerator? X minus 1. It might cancel with the x minus 1 on the bottom. So I think this would cancel with that, leaving me 1 over radical x plus 3 plus 2. We're doing the limit as x approaches 1. So I'm going to replace that x with a 1. 1 over radical 1 plus 3 plus 2. I believe it would give me an answer of 1/4. Okay, so that one was rationalizing. leaving us L'Hopital's rule, which to be honest we can't get to till I teach you how to do derivatives. So we will be getting to L'Hopital's rule. Now there are some special limits I suggest you just accept. So if you haven't written these down yet, write them down. See if they can make it up into the head and the brain. Yes. Okay, we're going to use these special limits and your trig knowledge to evaluate some things like these. So I know that if I put in 0, I get 0 over 0. So I'm going to have to manipulate it. If all else fails, go to sine and cosines. Tangent is sine over cosine, right? How do you divide by x? That's the same as multiplying by 1 over x. So if I was to rearrange this, I think I would have something like this. This limit is by definition 1. And when you put in a 0 for your x, you get 1 times 1, making this value 1. One of my special limits, I think, was the limit of the sine of x over x as x approaches 0. Now, there's nothing specific or special about x. It could be y's, right? Could be u's. In other words, if I can make this and this the same, the limit would be 1. But I can't just put a 4 there. What would happen if I multiplied by 1/4? Well, I can't do that unless I also multiply by 4. So what I'm going to do is I'm going to pull this 4 out front. So I'm going to put the 4 out front, leaving me now the sine of 4x over 4x. So I now know that that's 4 times this limit is 1. So my result here would be 4. If you set up your trig table like this, I think we can create it relatively easily. What we want to do is we want to count from 0 to 4. So I'm going to count from 0 to 4. 0, 1, 2, 3, 4. Excuse me. Then you're going to take the square root and divide it by 2. The square root of 0 is 0 divided by 2 is 0. Square root of 1 is 1 divided by 2. Square root of 2 divided by 2. Square root of 3 divided by 2. What's the square root of 4? 2 divided by 2 makes us 1. Cosine, you just go in the opposite order. So instead of starting with 1, it starts with a 0. You'll notice a 45-degree angle, which is pi over 4, is the same for sine and cosine, goes to 1/2, and instead of starting with 0, it ends with 0. If you're interested at 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, namely the first quadrant. Now, if I wanted to add something to this, I might realize that sine over cosine is tangent, and I could just add that to my table pretty easily. Tangent is sine over cosine. 0 over 1 is 0. I'm going to skip this. Anything in the middle, anything divided by itself is 1. If you have this divided by 1/2, that means times the reciprocal, which makes this radical 3. 1 over 0, most people think is undefined. Eventually, we'll get you to think of it in terms of infinity. And if you actually do this division, you get radical 3 over 3. So now we have all the trig values for the first quadrant. The only thing you might have to do is adjust them for other quadrants. such as the sine of 11 pi over 6. A complete circle is 2 pi, which could be 12/6. 11/6 is how much less than 12/6? That's called your reference angle. Excuse me. Reference angle will be pi over 6. So I look up the sine of pi over 6. I get 1/2. In the fourth quadrant, it's positive, negative, cosine, sine. So the sine of this sine should be negative. Now, you can look at these if you wish. You can look at a channel on YouTube. The YouTube channel, the MR Calculus. And there's something there called the trig table. That's one of my renditions of it. There's plenty of good ones on the internet, but you do need to know these values. I hope this helps.